All right, here, so we have what I would say is a pretty difficult problem, and you can see that it's broken up because of this hence. It's broken up into two problems, so they're giving you a huge hint that you will need this relationship. And then here's our integral. So we'll start with part A using long division and show that this is true. So this says that u squared plus 1, when divided into u squared, that should be this. So u squared into u squared is 1. Multiply down, we get u squared plus 1. And then subtract. This is 0, and this is minus 1. So then, if you remember, you leave this minus 1 over this piece here, your remainder, just like from grade school. Okay, so that's true. That's part A. Part B, it says to show that this says to use u equals to root x. So u equals to root x, which means du is equal to 1 over 2 root x, the derivative of root x, dx. All right, so I clearly don't have this in here. So what I'm going to do is I'm going to rearrange this a little bit, but so let's just say you're stuck here. You don't really know what to do. My advice to you is to start doing some substitutions and see if you can get every piece out. So what I'll do is I'll multiply 2 root x on both sides. So I have 2 root x du is equal to dx. Now I need to get this in terms of u. Well, luckily I have a root x right here. So that's 2u du equals dx. So now I can start doing my substitutions. 2, and then root x is equal to u. And then I have dx, which is equals to 2, which I already have. And then u du, so that's another u, makes that squared. And then du. And now I need to take out 1 plus x. And you can see here that if I square both of these, I get u squared is equal to x. And then x plus 1 will be u squared plus 1 equals x plus 1. So this is that last piece. So u squared plus 1. Now look, this is exactly what we have here. So now that I've already shown that, I can just use it. So that's 2 integral of 1 minus 1 over u squared plus 1 du. Take the integral, we have 2 u minus, now you'll remember from earlier, we have a 1 over u squared plus 1, that is arctan of u plus c. And then just substitute your u. We have 2u, which is root x, minus arctan of root x. And we are done. So that I would say that that's a fairly difficult problem. You've got arctans, you've got some interesting u substitutions, and long division.